Now I'm going to introduce the product rule of probability. So this actually links to what we've learned in the previous part just then. Now I'm going to go straight into the question so you get the idea. Starting from question 9, and they give you probability of A, B, C and D in the question. Part A, they want us to find probability of A and B. Probability of A and B is simply probability of A times the probability of B, which becomes 1 on 24. Before I continue, I just want to point out two important things. That's all you need to remember for this part. Remember in the previous one, the addition rule, that's when we have or. Probability of, say, A or B, given that they're independent events, they're not dependent of each other, we can say that it's probability of A plus the probability of B. This is what we've learned. So whenever you see or, remember that it's plus, addition. That's why I introduced the addition rule. So don't think of it too complicatedly. Just remember or is plus. Okay, so that's the first case. Now the second case is this case here, when we want to find the probability of A and B. What do you think will happen here, guys? If it's and, you simply do the probability of A times the probability of B, and that's all you need to remember. Or plus and times, just remember it like that. That's why here we multiply the two probabilities and we get 1 on 24. B, probability of A and B and C, so it's and, so we multiply. So we simply multiply the probabilities A, B and C, just like that. And you can calculate that to get 1 on 96. Find the probability of A and B and C and D. It's all and, so you simply multiply them all, just like this. And then you get that. Single digits are being generated randomly, so like these kind of numbers. It doesn't have to be a 5-digit number, but these are the kind of things randomly generated. It can be any random number. It can be repeated or there's no limit to this. So it's like these kind of numbers. These are just examples. In part A, I want to find the probability that the first 3 digits are 1. How many numbers can we choose from, by the way? We can start from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there's 10 numbers we can choose from, and I want the first 3 digits to be 1. We want the probability of having 1 for the first number, and 1 for the second number, and 1 again for the third number. And we know that the probability of getting 1 is just 1 on 10. It's simply 1 on 10 times 1 on 10 times 1 on 10. It's going to be same for the first, second, and third number. 1 can be repeated. There's no limit to how many times I can use 1. So it's just that. B, when the first 2 digits are less than 5. Well, less than 5 is including 1, 2, 3, and 4, and including 0. So there's going to be 1, 2, 3, 4, 5 possibilities we can have. So if I want the first 2 digits to be anything out of these numbers, first number is less than 5 and second number is also less than 5. Now that less than 5 is going to be 5 out of 10, and having another second number less than 5 is also 5 out of 10. And because it's this and this, we multiply. And you should get 1 on 4 if you simplify it. Find the probability that the next digit is a 3. The first 3 numbers were already 3, but we want to find the probability that the next digit is a 3 as well. Does it matter what the previous numbers were? The next number depend on what the previous numbers were? No, all the numbers in all the digits are independent of each other. So even if the previous number was 3, even if the previous number was 0, even if the previous number was 9, it doesn't matter. The next number will always be independent. Probability of getting 3 for the fourth number is also just 1 on 10. D, if the first 4 digits are all 9s, find the probability that the next 3 are 4s. Does it matter if the first 4 digits were 9 or 0 or 2 or 5? It doesn't matter. They're just putting that in to trick you guys. So don't get tricked. All independent of each other. So we know that getting a 4 is 1 out of 10. So if I want to find the probability, I simply multiply 1 out of 10, 1 out of 10, 1 out of 10 for the next 3 numbers. So we multiply 3 times, which will get you 1 over 1,000. Question 11. A machine can detect car registration numbers with probability of recording error of Q. So there's an error of Q. We don't know what that Q is. There's a probability. Find an expression for the probability that there are no errors when he records N registration numbers. getting an error is probability of Q, the probability of not getting an error is going to be 1 minus Q, because 1 is the total probability. And if I subtract Q from that, that will be the probability of having no errors. Because just remember that, 1 is the total probability. If I want to find an expression for the probability that there are no errors for n numbers, then it's like this. No error and no error and no error and no error for n times. And we multiply, so it's going to be 1 minus q times 1 minus q times 1 minus q n times, so it's going to be 1 minus q to the power of n. That's why we have this expression. So this is your answer, guys. 12. A class consists of 9 boys and 16 girls. 2 of the boys and 4 of the girls are fair-haired. 1 of the boys is chosen at random and 1 of the girls is chosen at random. Find the probability that both are fair-haired. And we know that 2 of the boys, so 2 out of 9 boys are fair-haired, and 4, so 4 girls out of 16 are going to be fair-haired. So those are the probability of each individual outcome. So if I want to find the probability of both being fair-haired, I want to find the probability that the boy is fair-haired and the girl is fair-haired. That's the probability of boy being fair-haired, that's the probability of girl being fair-haired, and because it's and, so we multiply. We just get 1 over 18. Just calculate that yourself and check. For all these probability questions, I always want you to relate that or is plus and is times. That's it. Okay, so it's going to be very simple for any of these probability questions.